Good afternoon. I'm Allison Hahn. I'm Program Manager for Advanced Methods of Manufacturing. So as you can see, the AMM vision and goals are to fund research that can build new plants cheaper and quicker. One method to do that is through modularization. It's used in many other industries, and we think we can apply that to the nuclear industry. These are the 4 focus areas this year. This is the 4th year that AMM has issued a solicitation, and we've managed to keep it fairly broad throughout the years. We have added a new area, advances in manufacturing processes. I'll go through that through each area next. I do want to reiterate that our awards are 3-year awards for $800,000 each. Field and factory fabrication techniques. We have practical shop floor applications, heavy lift and load leveling equipment, and strength-assisted tooling. Practical shop floor applications include surface modification, metal spraying techniques, and then heavy lift should enhance the movement in both factory and field environments, and strength-assisted tooling should improve the efficiency in both factory and field workers as well. Assembly and material innovation to enhance modular building techniques. We have advances in high-strength concrete and rebar, pre-assembled rebar systems, and innovations in concrete. I do want to go through the first and the third bullet here to clarify. The first bullet, we are looking for new concrete and rebar systems, while the third bullet should utilize those advances in the concrete and rebar materials and design structures that utilizes those advances. So those are the two, that's how those two are delineated there. Okay. Advances in modular construction. This section is focusing on fuels components. We had advances in manufacturing processes, manufacturing methods for individual components, and cladding and surface modification methods. A few points to make on this slide. It does have to tie to manufacturing. We are not looking for materials development in this work scope. Slide 4, it did have surface modification and metal spraying techniques. The difference between that aspect and the cladding and surface modification methods here. Slide 4, it was known applications that can be applied in the shop environment. This one is development of new applications and methods. Some examples are the replacement of welding cladding on the interior surface of reactor vessels. Another example is valve discs, wear and surface corrosion applications. So I did just want to point out those differences as well. Lastly, improved concrete inspection, acceptance, and construction methods. We're looking at new concrete pour inspection and acceptance techniques, and then also other methods for measuring the curing of concrete during pouring. These next 2 slides go over our previously awarded projects. I just wanted to lay them out here to show what we have awarded, what we're currently doing, what can be continued. The FY11 awards are NEET projects that are ending this year, and then the FY12 and 13 projects will be ending in the next couple of years. Examples are the EPRI project. It began as a fossil energy project and led into manufacturing large nuclear components. To see where that kind of started. The Purdue project rose out of problems industry was having. Several nuclear plants utilize SC walls, and the ACI 349 code and the AISC code did not acknowledge SC walls, so they had to do extra testing. So this project hopefully mitigates that and increases the licensing schedule. The FY13 projects, just an example of what's going on again. The Georgia proposal is self-consolidating concrete mixtures that should eliminate the need for specific concrete delivery by allowing cold joints. Again, greatly simplifies the design and schedules. So those are just some examples of what's ongoing currently. Summary of expectations. The technologies that we are looking for should increase the reliability of nuclear power plants while also decreasing the costs. All of our products should gain regulatory acceptance, and also lastly, should any specific products be developed, they should be licensed for commercial nuclear applications. And then lastly is our contact information. Myself, Federal Program Manager, and then also my technical lead, Jack Lance, if you have any specific technical questions that you can answer.
Allison, right now we don't have any questions. If you do have a question for Allison or Jack Lance, he is on the line to answer any technical questions you may have. We'll start with this first question. It says, I couldn't hear what Allison mentioned as an example of corrosion. Could she please say that again?
So if you're referring to the slide 6 examples that I gave, the valve disc is an example that we tend to use here for the wear and surface corrosion applications. The other example I gave was replacement of welding cladding on the interior reactor vessels.
Is there interest in manufacturing techniques for metal or plastic joining?
I'm going to refer to Jack. Metal joining, yes. Plastics, Jack, I'm going to refer to you on that.
Yeah, the only, can you guys hear me?
Mm-hmm.
Yes,
yeah, the only technologies that I'm aware of where plastic joining would be appropriate, and there's an awful lot of work being done right now, or is on high-density polyethylene pipe for nuclear power plant applications in low temperature, low pressure buried systems like raw water systems, that sort of thing. So typically non-safety or class 3. But there's a lot of work being done on that. Certainly metal joining technologies, absolutely. We still believe that there's a long way to go, even though we've taken tremendous advances in welding and joining materials together. We still believe that there are lots of opportunities in that area.
When referring to manufacturing, is that related to the manufacturing of the reactor or in the processes used to make materials for the reactor?
Manufacturing reactor components, if I'm understanding that question correctly, not making the materials, but the components of the actual reactor.
Are you also looking for innovative concrete ideas?
Yes. A couple options that we're looking for there. New concrete chemistry and rebar, and also rebar. Those interactions between concrete and rebar, and then new design structures of concrete structures.
Does this area include additive manufacturing?
Yes, it does. It's one of our main components of this program. We do have a few additive manufacturing proposals already, and we are still looking at other additive manufacturing processes as well.
How prominently do you think concrete research will be emphasized in the upcoming NEET-1 area?
We have a few concrete areas that we're looking at. Again, on slide 5, we have a couple different options. Sensing of the concrete pores and curing is also included on the last area as well. So there's a few options for concrete.
Is solid-state joining techniques of interest?
Yes. I want to defer to Jack to go into more detail on that, however.
Yeah, solid-state joining is always of interest, but it has to. One of the criterion that we use to evaluate research projects for this program is that can it be practically applied within the next 3 to 5 years in general. And so solid-state joining, things like friction stir welding, yes. Things that may exist in other industries that could be applied, yes. But some solid-state joining technology is very, very researchy, and we don't think it would ever be applicable in the next, say, 5 years. So that's the distinction we would draw in looking at a project.
Innovation in concrete through reduced volume and thickness may involve higher costs. Is a study on mass scaling these type of techniques to reduce cost acceptable?
I might have to defer on Jack. I'm confused how.
Well, I think I guess I understand the possibility of higher costs. In the end, it would be the aggregate cost during construction. So higher costs for materials or higher costs to form up the concrete, but but those two higher costs that allow for a much shortened construction time would be weighed just in that manner. If the overall impact is higher costs for the actual construction, which includes time and cost of money and all of that, then the answer would be we probably wouldn't be interested.
Would you be interested in reducing thickness and complexity of concrete containment structures through the use of SC technology?
Yes, those are one of the areas that we're looking at, yes.
Does this area deal with concrete degradation in any way?
No. No, we're looking at new builds. So.
To confirm, was it said that there was interest in rebar material development in this program?
Yes. Jack, I don't know if you want to expand on specific examples, but that is one of the areas that we are covering.
Yeah, I think rebar development is a key area. Once again, you know, we'd like to find rebar development research projects that could be, you know, brought to at least the industry within the next 5 years. But alternate rebar materials, alternates for rebar, yes, absolutely. We're always interested in those sorts of things.
Some attendees just want to confirm your email address, Jack. It is jacklance without the E at gmail.com, correct?
That's right. That's exactly right.